In this video, we're going to be looking at rationalizing denominators. So before we start, there's two kind of key techniques that we're going to be looking at when we actually do today's method. They're both quite basic techniques, but in case we go over them, it might cause a few issues later on. So the first one is if we have 1/3 and we times it by the same 1/3, so we've got root 3 times root 3. Well, from a previous video, we said if we have 2/3 multiplied together, we can just times those numbers together. So 3 times 3 is 9. But we actually know what the square root of 9 is. It's actually 3. Now, the key technique that we need to remember here is if we have this irrational number and we multiply it by the same irrational number, it actually becomes a rational number. And the number it becomes is just whatever was inside the surd in the first place. So root 3 times root 3 equals 3. We've gone from irrational, irrational to rational. So that's one thing we're going to be looking at later on. The other thing is, and this is quite a very basic technique, is anything times by 1 is still itself. It hasn't changed. So 5 times by 1 is still 5. But what we could do with this 1 is we could write it in a different way, because anything divided by itself is still 1. So if I had changed that 1 to 7/7 and wrote 5 times by 7/7, well, that would be 5 times 7, which is 35, over 7. It's still equal to 5. We've just written it in a different way. These two things here are still exactly the same. These two things here are exactly the same. We've just written it in a different way. And it's going to be these two techniques that help us do a technique called rationalizing the denominator. So what that means is we're going to get a question where there's a fraction and the denominator at the moment is irrational. So if we look at both of these two examples, we can see that the top thing may be rational, it may be irrational. We don't really care about the numerator at the moment. The key thing is at the moment, the denominators are both irrational. And the question wants us to make the bottom numbers rational. And to do that, what we're going to do is a combination of the two techniques that we did on the previous page. We're going to times both of these by 1. Because we've just said if we times things by 1, they're not different, they're exactly the same. We've just written them in a different way. But rather than timesing it by 1, looking like this, we're going to actually change the way we write that number 1. And all we're going to do is we're going to take whatever the surd is at the bottom and we're going to times it by that surd over itself. So for this first one, we're going to times 3/7 by root 7 over root 7. So we're timesing it by 1. It's not changing. But what's going to happen now is when I do the multiplication, so this is top times top, bottom times bottom. 3 times root 7 is 3√7. And root 7 times root 7, a surd times by the same surd, just equals whatever number it was. And that is my answer. There's nothing else I need to worry about here. The question said rationalize the denominator. We want the bottom number to become rational. The bottom number is now rational. We don't have to worry about the fact that the top was rational and now has become irrational. There's nothing wrong with that. The key part is make this bottom number rational, and that's what we've done. So the same idea for the bottom one. Rather than timesing it by 1, we're going to take the surd and divide it by the same surd, so we're timesing it by 1. See what we get. We get 4 times root 2. That's 4 root 2's. And at the bottom, we've now got 3 times root 2 times root 2. Well, root 2 times by root 2 is going to be 2. Times by this 3 means our bottom number is now 6. So there's my answer. For this one, what we could do is we can simplify it even more, because we should know that 4 over 6 is the same as 2/3. So we're going to get 2 root 2 over 3. So these ones are quite straightforward. If there's only one thing at the bottom, just take that surd, whatever surd it is, write it at the top, write it at the bottom, and do a times. Take the surd, whatever it is, write it on the top, write it at the bottom, and do your multiplications. Now it does get slightly more complicated, and that's when we have something that looks like this. And as you can see now, the surd is not by itself anymore. There's now a plus or a minus involved with these questions. Now I'm going to start off by doing this the wrong way, just to show you why we can't do what we've previously done on the other questions. So if I take this top one, you might be tempted now to think about writing it as times in by root 2 over root 2, so that the top becomes irrational, but the bottom would now be 1 times root 2, which is root 2, and a root 2 times a root 2, which is 2. And that hasn't really helped us. The denominator here was irrational because of this root 2. We've still got an irrational denominator because there's a root 2 involved there. So this idea at the moment does not work. What other people might try and think about doing then is, well, let's do it as 1 plus root 2 over 1 plus root 2 and see if that helps us. So on the top we'd get 3 plus 3 root 2's, and on the bottom, well, this is now going to be a FOIL question. We've got one bracket and another bracket, so we'd have 1 times by 1. We then have to do the outsides, which is 1 times by root 2, insides, which is root 2 times by 1, and then lasts, which is root 2 times root 2, which is 2. And again, that hasn't helped us because we've got 3 plus 3 root 2 at the top, and on the bottom we've got 3 plus 2 root 2's. So that idea did not work either. But actually we weren't a million miles away by doing this, because to rationalize these denominators, what we need to do is very similar to this. Brackets. And all we had to do was change this sign in the middle. So the denominator here said 1 plus root 2. What we are going to do is we're going to times it still by 1, but it's going to be 1 minus root 2 over 1 minus root 2. It's exactly the same as the thing at the bottom, but the sign has changed. And now if we multiply them together, on the top we get 3 minus 3 root 2's. And then when we multiply at the bottoms, by doing FOIL again, we get the first is 1 times 1, which is 1. The outsides get us a minus 1 times by root 2. The insides get us a plus 1 times by root 2, which is positive 2. And then the lasts, so it's root 2 times root 2, which is 2, but it's a positive times by a negative, so we get a negative. On the top, we're left with 3 minus 3 root 2's. And on the bottom, these surds are going to cancel out. If we need to take away a root 2 but add a root 2, they disappear, and we're left with 1 times by minus 2, which is minus 1, And we can either leave it like that, or if we divide each bit on the top by -1, what we would get is -3 plus 3 root 2. So the key thing with these questions, if the surd is not by itself, like on this one here, is multiply it by the same thing, but change the sign. It does actually have a name, this thing. It's called a conjugate. So a conjugate of something is exactly the same, but the sign has changed. So if you had something like 5 plus x, then the conjugate would be 5 minus x. It's the same thing, but the sign in the middle is the opposite sign. So let's now try and do this last one. And the reason this last one's going to be even nastier is because the top, the numerator, is also irrational at the moment. Now remember, we don't need to rationalize numerators, we just need to sort out the bottom. So the trick is, we're going to times it by 3 and root 2, and 3 and root 2. And because this one was a negative at the bottom, we're now going to multiply by 3 plus root 2 over 3 plus root 2. That gets us, on the top, 4 times by 3 is 12. 4 times by positive root 2 is 4 root 2's. Insides, root 3 times by 3 is 3 root 3. And the lasts is root 3 times root 2, which is root 6. So the numerator here is very messy and very ugly. Lots of irrational numbers there. But on the bottom, we have 3 times by 3, which is 9. We have 3 times by positive root 2, which is plus 3 root 2's. We have a minus root 2 times by a 3. That's minus 3 root 2's. And then we have negative root 2 times by positive root 2, which is minus 2. Now we can't simplify the numerator here because we have one rational number and then 3 different surds. So the top is going to have to stay the same. But the bottom, the denominator, can simplify because the positive 3 root 2's is going to cancel out with the negative 3 root 2's. And that's going to leave us with a 9 and a minus 2. And 9 minus 2 is 7. And again, we have rationalized the denominator. So the 2 different techniques that you need to remember for this is if the surd is kind of by itself, just times top and bottom by that surd. And if the surd is not by itself, if it's got a plus or a minus part to it, multiply top and bottom by the conjugate of that denominator. The same thing, but with the different sign.